At least I got it now. All right, so we need to know that. The second thing we need to know is that if we're given a point on a line and we're given the slope of the line, that we can find the equation of the line. There's a big difference between just having the slope of a line and then having its actual equation. So the way we do this, if you're given, right, so you're given a point and you're given your slope m, right? So you have two things, a point and a slope for a line. Then the equation of the line is we're going to use this formula. There was a formula back in college algebra. It's this one right here. That is called the point slope formula. That is the formula we use to actually find the equation of the line that goes through those 2 points. So now what I'd like to do is I'd like to do a specific example, all right? I want to do a specific example. So let me go back to my picture here. Let me take this out of here. Or was it there? And there. Okay, I'll zoom in a little bit. Everybody see those 2 points, 1, -1, and 3, 9. What I'd like for us to do is find the equation of the line that goes through those 2 points, all right? Find the equation of the line through those 2 points, 2 points. I'm gonna go ahead and copy this, put it into my notes here, start a new page. So I'll make that a little bigger. So I want us to find the equation of the line through 1, -1, and 3, 9. All right, so I've given you 2 points, and now I want the equation of the line that goes through those 2 points. So to find the equation of the line, you need 2 things. You need a point and you need a slope, right? That's what you need, a point and a slope. Well, in terms of a point, I can call this x1, y1. I can call this one x2, y2, right? And so I have 2 points. I can choose either one. Doesn't matter which one I choose. So I'm just going to choose this one as my point. So I'm going to put here, I need a point and I need the slope, right? The point is that point right there. Now, to get the slope, we're going to just use the formula rise over run. So the slope is going to be rise over run, which will be y2 minus y1, oops, over x2 minus x1. And let's see, what happens here? We get y2, that's the 9, take away y1. So you have to be careful there because you're subtracting a negative, right? So when you subtract that negative, it becomes a plus. And then you take the x2, 3, and you subtract the 1, that gives me 2. And so you get 10 over 2, which is 5. So that's the slope of the line, right? So we have a point, we have a slope. And now we just go to the formula that I just showed you, y minus y1 equals m times x minus x1. Replace x1 and y1 with 1 and -1 respectively, and then replace the m with 5, and we should have the equation. So y take away -1 equals 5, and then x take away 1. Y1's going here, x is going here, m is going there. And this just becomes y plus 1 equals 5 times x minus 1. And that right there is fine. That is the equation of the line. And we're okay with just leaving it like that. Now, back in college algebra, what you would normally do is solve this for y. Like you get y by itself. So I'm going to do that as well so that you can see how that would work. I just distribute 5 through. And then distribute the 5 minus 5. And then now I would subtract 1 on both sides, and I get y equals 5x minus 6. There we go. Okay. Any questions? All right, so what I'm gonna do now is I'm gonna go back to Desmos and I'm gonna graph that line that we just got, y equals 5x minus 6. And when I do this, we should see a line get drawn between those 2 points. There we go. All right, so we were able to calculate the equation of that line that goes through those 2 points. None of what I've done so far should look like something you've never seen, right? At some point, you should have done this in the past. All right, now let me tell you what we're going to try and do. All right, this first part was just getting the mechanics down of the algebra, type of algebra stuff we're going to need to do. So kind of clear your minds a little bit. I want us to take a look now at a function. Okay, so there is a function, and that is actually the function. You can see it up here in the top left. That is the function f of x equals x cubed minus 2x squared. All right, so remember, like, what we're trying to do is at some point be able to find the peaks and valleys of this thing, right? But just table that for now, okay? We're gonna get back to that. Do you all see that those 2 points that we just found live on that graph? You'll see that one of the points here, 1, -1 lives on the graph, and then this point 3, 9 lives on the graph. And what we did is we found the equation of a line that goes through those 2 points, right? What we really want to do in this class at this point is this. Let me clear that out of here. We want to imagine a line connecting, oops, where is this? Hold on. There we go. We want to imagine starting here at this point, 1, -1. Okay, this point down here. I'm going to change the color of that one. Let's change it to orange. No, black. There we go. Okay. You'll see that point down there. We're gonna treat that as like what I'm gonna call our anchor point. That point's not gonna move ever. It's always gonna stay there. And then this point that's on the graph, 3, 9, I'm gonna start to move it. And I want you to notice what happens to the line connecting these 2 points together, all right? Right now, I have the computer calculating the slope of that line, right? So the line connecting those 2 points on the graph is called a secant line. So the computer is calculating the slope of that line, and we had already done this by hand, right? We found that the slope was 5. But now I'm gonna start moving that point closer. So watch what happens. I'm gonna start dragging that point closer and closer to this black point. So what I mean is I'm moving to the left, right? And as I move to the left, I have to move along the graph and the point's coming down. But notice the slope of the line, right? It's no longer 5, it's now 3.59 or something like that. And I'm going to keep moving, keep moving, keep moving. The slope is still there. It's going to go to flat and then go a little bit negative slope, right? Remember, a negative slope is when it pitches down when you go from left to right. If the line goes down, then it would have a negative slope. And then I keep moving, and can anybody tell me what's going to happen when those 2 points land on top of each other? Any ideas? Any guesses?
There's gonna be no slope.
I'm sorry?
There's gonna be no slope because it's just that point.
Yeah, so when you drag the 2 points on top of each other, right? Think about that formula. Think about the formula that we had for slope, right? Right here. To calculate the slope of a line, it's the difference in the y coordinates over the difference in the x coordinates, right? But if it's the same point, right? If you move that second point right on top of the other point, they're the exact same point. So what would the difference of the y coordinates be in that case? If they're the same point, what would the difference of the y coordinates be?
Nothing.
0, right? So that would be 0. And then what would we get on the bottom? What would the difference be?
Also 0.
Also 0, right? And 0 over 0 is undefined. Now, don't confuse what we've been doing in this class. When we take a limit and we get 0 over 0, we have ways to figure out an answer. But 0 divided by 0 is undefined. So when I drag that second point over, what should happen, it's going to be kind of tough. I'm trying to do it. Right there. Okay, look what happened. The computer said, shit, I can't do that because you're trying to get me to do 0 over 0, and I can't do 0 over 0, right? So there's an issue. Now, even though there's an issue, let me drag a little bit further, go to the other side of it. See, if I move off that point a little bit, then I, again, start to have a line again, right? And the slope. So even though at 1, there is no slope, it seems like there is a line though, right? Like it looks like when I get really close, let me move this in, zoom in a little bit. Do y'all agree that as I get closer, that sorry, I'm trying to make this a little easier for me to do here. There we go. So do y'all see that as I get closer, notice what the slope of the line is right now. It's negative 0.824, right? That's the slope of that line. Notice as I move that red point closer to the black point, what happens to that slope? Negative 0.92, right? It's getting, what does it seem like it's getting closer and closer to?
1.
Negative
1.
Right? Looks like it's wanting to get closer and closer to negative 1. Like it's obviously not, this slope is obviously not a positive number, right? It's a negative number. It looks like it's getting closer and closer to negative 1. But as soon as I get it on top, I get undefined, right? But it looks like anywhere close to that point, and the slope is negative 1. Do you think there's a way that we can figure that out? Like just by looking at the function without having to draw the picture and do all this stuff? I mean, do you think that there's a way that we can get ourselves around the whole 0 divided by 0 thing? Well, that's what the limit was all about, right? The limit was a way to get around that. So this section, right, our goal for this section, not the whole chapter, but for this section, is to see if I give you a function, right? If I give you some function and I give you some point on that function, can you tell me what the slope of the line through that point would be? So we want to know, can you actually find that one, that true slope? I'm going to put the other one back up there. We know that when we get close, right? When we get close, it's looking like it's getting closer and closer to the slope of that black line. Can we find that ourselves, right? Can we figure that out is the goal, all right? So let me try and see if I can develop this idea now. This was just to get like a geometric idea in your minds, but let's try and develop it algebraically, all right? All right, so I'm going to start drawing some pictures. I'm going to start with some graph here, whatever it is. I'm going to call that function f. And I'm going to pick my anchor point, the point that's not going to move. I'm going to call that A, all right? And so this point right here has an x and a y coordinate. The x coordinate is A, and the y coordinate is whatever I get when I plug A into that function. So like if this were the function we were talking about a second ago, right? I plugged in 1, right? 1 is where I am on the x-axis, and the negative 1 is what we get when we plug 1 into that function. So if you plug 1 into this, it spits out negative 1, right? So that's just to remind you, that's what that means. Okay, so that's that point. And then I'm going to pick some other arbitrary point to the right of this point. So I'm going to pick some point over here. I'm going to call it x. I could have called it anything I want. I'm going to call it x. And that point would have the coordinates. X would be the x coordinate, and then the y coordinate would be whatever I get when I plug that x into the function. All right. Now, my question to you is, for us to find the slope of that secant line. Again, we call it a secant line because it is the line that connects 2 points on a graph. If the graph wasn't there, then I wouldn't be talking about secant line. But the fact that those 2 points live on a line or live on a curve, I call it a secant line. So the way I'm going to write this, the notation is I'm going to put M, and then underneath it, I'm going to put SEC. That way you know I'm talking about the slope of the secant line. And the slope of the secant line should be rise over run, right? Rise over run, just like before. And the rise should be the difference of the y coordinates. I'm going to write here y2 minus y1 over x2 minus x1. And for us, we're just going to treat this as x1, y1 here. And this one is x2, y2 here. So can somebody tell me what the numerator of this fraction is going to be? What do I write down?
Fx minus a
F of x minus f of a. Good. And then what about the denominator?
x minus a.
X minus a. That's it. So you're just taking the difference of the y coordinates and you're dividing by the difference of the x coordinates. Everybody clear on the idea that that right there, whatever it is the slope of the secant line. Yes? All right, further, what if I now asked you to find the equation of the secant line? Well, what do you need for the equation of a line? A point and a slope. Do we have the slope? Yeah, here's our slope in yellow. Do we have a point? We actually have two of them, right? We have two of them. I'm going to use this one right there, that point right there. Okay, so this is my point. And then over here, this is my slope. And then I'm going to use that formula. I'll put it here. Y minus y1 equals m times x minus x1. Now this is going to look terrible, but let's just write it down. Y minus, now y1 for us is f of a equals, now the slope, right? The slope is going to suck. It's this thing. It's really ugly, but that's what I'm going to write down. So my slope is f of x minus f of a over x minus a. And then I still have down here x minus what? What's x1 for us?
A.
A. X minus a. Good. There it is. That is a generic formula for the equation of a secant line at x equals a. So remember my anchor point, the point that I wasn't moving, that a right there in blue, right? That's where I'm looking for what is the slope of the secant line at that point. All right. Now, remember I said what we want to do is we want to take that point on the right and we want to slide it over and get it closer and closer and closer and closer to the black point, right? We want to move it over. And if we could put them right on top of each other, our formula is going to fall apart, isn't it? Like if I move this x, if I move it all the way over and the x becomes an a, right? The x actually becomes a. Do y'all see that right there? That would basically give me a 0 over 0. I'd get 0 on top and 0 on the bottom if I replace the x with a. So I don't want to replace x with a. What I want to do is let x get closer and closer to a, right? Without actually ever getting there. How do you think I do that? How have we been doing that in this class? Let something get closer and closer without actually getting there.
Finding the
limit.
limits.
Yeah, we do a limit, right? That's it. We just do a limit. Okay, we're going to do a limit. So using this same idea, I'm going to continue this logic here. I'm going to say, if you want to find the slope of the tangent line, now the tangent line is that line that we're after. I mean, this is really what we're after. Going back to this picture, we are trying to find this black line. The blue line is us sliding the point over, but ultimately we want to find the slope of this black line and then find the equation of it. So that's the tangent line. So to find the slope of the tangent line, if you're asked to do that, what you're going to do is you're going to use the same exact formula that we had here. Same exact formula with one exception. We're going to take a limit of it. That's the only difference between the secant one and the tangent one, is that before we start, we're going to do limit as x gets closer and closer to a of the rise over run, which was f of x minus f of a over x minus a. See, there's only one difference between the slope of the secant line and the tangent line, and that's a limit. And then if you want to know the equation, right? If you want to find the equation of the tangent line, then you're going to use that formula that we put in the box here. But instead of this in front, you're going to put a limit in front of that. So it's the exact same formula. Y minus f of a equals the limit as x approaches a of f of x minus f of a all over x minus a, and then over here in parentheses, x minus a. Okay, these two formulas are the huge takeaways from today. All right, we're going to now use these formulas. All right, let's do it. Let's do it for, well, that probably is, we're not ready for that. Let's start with a simple problem, okay? Let's start with something easy. Given, this is your first example here. Given the function f of x equals x squared, right? Find the equation of the tangent line at x equals 3. I'll go back to that. Let me copy this and bring it over so we can use these formulas. I'm going to make this a little smaller. There we go. Okay, so I give you a function, right? And I ask you to find the equation of the tangent line at the value x equals 3. So let's do this in pieces. Instead of going right to this formula right here, let's see if we can figure out what this is first. Right? Let's figure out that blue part, which is really this, right? Which is just the slope of the tangent line. So we're going to figure out what the slope is first. And once we figure out what the slope is, then we will go figure out the equation. All right. So let's write down that formula. The slope of the tangent line will be equal to the limit as x approaches a of f of x minus f of a over x minus a. All right, that's just me writing the formula down. Now, can somebody tell me what a is for us in this particular problem? What's a?
X squared.
I'm sorry?
X squared.
That's the function. The function is x squared. So this is a little bit tricky. Let me go back to this. Okay. So remember our anchor point was A. That's the point we're going to leave alone, and then we're going to move the other one towards it. Notice that when I wrote this formula here, I said this formula would be the equation of the secant line at x equals A, right? So when you're given the problem and it says find the equation or secant line at x equals, let's say 3 or -2 or whatever it is, this number right here will always be the A. That's the anchor point, all right? So I'm going to rewrite this limit. And I'm going to let x get closer to 3, right? Think about it. We have an anchor point at 3, and we want to let the x get closer to it. Then I write f of x minus f of 3 over x minus 3. So I will highlight again, and I'll do it in, well, I'll circle it. All I did is I replaced all my a's, right, with 3's. That's all I did there, right? We need to figure out what this is, right? We need to figure out what this is. So I'm going to need you to help me with this. I'm going to take those circles out of there. This is equal to the limit as x approaches 3. Okay, can somebody tell me what f of x is? Well, what's the function?
X squared.
X squared. Okay, so I just write x squared there. All right, great. Minus, can somebody tell me what f of 3 is?
9.
3 squared.
9, 3 squared, right? So all f of 3 means is plug 3 into the function, right? So 3 squared is 9. So I put that there. And then all of that is over x minus 3. There's nothing to do there. And now all the work that you've been doing over the last few weeks, right? Working with limits and figuring out limits and limits and limits. Now you get to actually do one, right? Let x go to 3. You get 0 on the top, 0 on the bottom, right? 0 on the top, 0 on the bottom means some algebra, right? This is bad. Okay, what algebra would we use here?
Difference of squares.
Difference of squares. So the top becomes x plus 3, x minus 3. And the bottom becomes, well, it's just leave it as x minus 3. And now you can cancel out the x minus 3's, and all you're left with is x plus 3. So let x go to 3 now, and you get a final answer of 6, right? So what we're saying is that for this parabola x squared, let me bring this up graphically. Let me save this. I'm going to start a new graph. Okay, so what we're saying is if you graph x squared, okay, and you go to the value of 3, I want 3 to show up here. There it is. There's 3. Let me squash this down a little bit more. So here's 3. Let me plot the point. The point we have is 3, 9, right? That's the point on the graph. So what we're saying is that if you were to try and find the tangent line to that curve at that point, the slope of it should be what? What did we just say? 6, right? That's the slope of the tangent line. What I need to know now is what is the equation of it so I can graph it. And when I graph it, we should see a line that just barely touches through that point. Let's get the equation. So we have the slope, right? That's the blue part. We've done that. We just found this. And now we're going to plug that into this formula right there. So let me write the formula down. I'm getting the equation now. So y minus f of a equals, now I'm going to put the 6 there because I don't want to write that big thing down again, the limit. We just did that limit. And then x minus a. And then didn't we say that A was 3, right? So we can just replace all of our A's with 3. And we also know that f of 3 was just 9.
I don't understand how you're getting 9.
By plugging 3 into the original function, right? When I say f of 3, I mean take the original function, which is x squared, right? And just replace x with 3. And 3 squared gives you 9.
Okay, thank you.
Yeah, a lot of students like for some reason they're like, well, where's that coming from? Well, we're just basically what we're trying to find there, Stephen, is if you look at the graph, we're actually trying to find just the y coordinate. That's all we're trying to find, is what's that y coordinate? All we knew was that the anchor point, the x coordinate was 3. So in the formula, we need to know the y coordinate as well. So we plug 3 into the function to get 9. Thank you for asking. All right, this is my equation. I'm going to clean it up. I'm going to distribute the 6 through. On a test, you don't have to do this. You could just box this and I'd be happy. But let's just do it. It's not, these numbers are not fractions or anything, so this should be pretty straightforward. Distribute 6 through on the right, add 9 to both sides. And you get y is equal to 6x minus 9. There we go. All right. So what I should see here is if I go graph this with the parabola, I should see a line that is tangent to that curve at that point. So let me graph it. Y equals 6x minus 9. There it is. You see? That's the best. Well, I don't want to say the best. Let me go back to this. Give me a second here. I'm gonna just do something real quick. F of m equals I'm trying to decide if I want to do this. You know what? I can probably do it with the other one. Let me do this. I'm going to change this function to just x squared. That's what I'll do. All right, there we go. Let me take some of this crap off of here. All right, so here's what we did. We had our parabola, right? We had our parabola. And what was our anchor point? 3,9, right? It was 3,9. All right, so this is what we did. We had our anchor point 3,9 here, and we were trying to find the equation of the tangent line through that point. So we took a point to the right and we slid it over, and keep an eye on the slope right here, 8.27, keep an eye on that slope. As I slide that point over, notice the slope of that line's changing. It's getting closer and closer and closer to what? 6, right? And if I actually get there, boom, right there, it's undefined, right? It's undefined, but we actually found it. We know that at that point, right? At that point, we actually do have a line, right? And we found the equation of that line. And we should theoretically be able to do this for any function, so long as we can do that, the limit, right? The limit is going to be the Achilles heel for us. Can we calculate that limit? As long as we can do it, we can come up with the equation of the line. All right, any questions? I'm going to do another example. We need to do a couple of examples to kind of see this all play out.
You said that you didn't want us to have to like solve the equation, right? You said that you'd be fine with that answer.
Yep, I'm okay with this. All right, let's try another one. Trying to figure out how hard I want to push here. Let's do this one. The one that I opened this whole idea with, this x cubed one. Let's do this one. So x cubed minus 2x. I think I have it ready to go. Let me see, where did I put it? There it is. Okay, so this right here, this is the function. All right, so I'm giving you this, given that function. I want us to find the equation of the tangent line at x equals 1. So we just need to remember now that that 1 is our a, right? That's our a. And we're going to use the formulas, right? Let me go grab the formula right here. So I'm not a huge fan of making students memorize things, right? But these formulas you do need to put into your brain for the test, all right? All right, here we go. I'm going to go after just the slope first. Just like we did before, I'm just going to write the slope of the tangent line formula down. That's going to create a limit, and then I'm going to try and calculate that limit. So the slope of the tangent line, by definition, is just the limit. X approaches a, f of x minus f of a over x minus a, which is the limit as x approaches. Okay, I'm going to start replacing things. A for us is 1. And then f of x, what's f of x for us? A big ugly thing, right? Big ugly thing, x cubed minus 2x squared, right? That's f of x.
Yes.
And then minus f of a. Okay, this is tricky. We have to do, what do we have to do? This is the question that Stephen asked, right? Like, what does this f of a really mean to us? It means we need to plug 1 into the original function. So what do we get when we plug 1 into this?
0.
When you get 1 cubed minus 2 times 1 squared, right?
So it's -1, right?
Negative 1. You should
Okay.
get negative 1. Got that, Lewis?
Yeah.
Okay. So I am going to subtract, be careful here. I'm subtracting, see that minus sign? I'm subtracting from the f of x function. I'm subtracting whatever I get when I plug 1 into the function, which we just said was -1. So it's a double negative, isn't it? It's a double negative, which will become a plus. And then all of that is over x minus a, but again, a was 1. Y'all following this? Any questions? Okay, let me clean this up a little bit. This is the limit as x approaches 1 of x cubed minus 2x squared plus 1 over x minus 1. If we can calculate this limit, then we can then say what the slope of the tangent line is there, right? And once we have that slope, we're going to use the other formula and just get a point, the point we're talking about, and then get that slope together and create the equation. But we need to be able to calculate this limit. So go ahead and try it, do direct substitution, and you're going to get 0 over 0, right? Everyone agree with that? This gives you 0 over 0? So this is bad. Algebra, trig, right? Now, before I started this example, I thought to myself for a second, like, do I really want to take you here on the second example? Like, am I ready to actually take you to where I'm about to take you? And I decided to go ahead and do this problem because I wanted you to see something weird, all right? Something we haven't seen before. We're supposed to do some algebra or some trig, right? But there's nothing that seems like we can do to make this better. Like, I really would love to see if I can make this x minus 1 go away by canceling it. So I need to factor the numerator out, right? What's the problem with factoring on the top? What's the problem? There is an issue.
There's no x on the +1 at the end.
Yeah, so you cannot treat this like a quadratic, right? Because this is x cubed, so you can't do that whole like AC method or whatever thing you learned to factor quadratics out. And there's no GCF to pull a greatest common factor out. So you are kind of stuck at this point, not knowing how to factor that numerator, right? You're kind of stuck. In none of the homework problems you ever had did this come up. So it's kind of not very nice of me to throw this at you right now, but it's going to force us to see if we remember something from college algebra, something called synthetic division. So let me see if I can remind you of this thing. So the way synthetic division works is synthetic division is a thing that we use in college algebra to help us actually factor things. It's a new factoring strategy. And so let me just do the synthetic division. And if this is like something you've never seen before, you're like, what in the world are you doing? It might be worth it for you to get with me or go to the tutoring lab and get a little bit of a refresher on it, all right? So what I'm gonna do is I'm gonna draw an upside down division box. And inside that division box, I'm going to put the coefficients of the polynomial that I see up top. I'm not going to worry about the x cubed, the x squared. I'm just going to put the numbers. So watch what I do here. I'm going to put a 1, a -2, a 0, and then 1. Why did I put a 0?
Because you're missing a value with just the x.
Yeah, I'm missing an x term. So I have to include a 0 for that spot. So I have a 1 in front of x cubed, a -2 in front of x squared. I have a 0 in front of x, and then a 1 by itself. Can anybody tell me that remembers this? What goes on the outside of the synthetic division box now?
Was it the X?
Not x.
I think it was 1.
It's the +1. So I don't know if whoever said x, I don't know if that's what you meant by it, but it's it's whatever number is here, right? You look at this number here and you take the opposite of it. So if you see -1, you put +1. If you see +1, you put -1. So I see a -1, so I'm going to put the opposite of it right there. The opposite of what I see there. And then once you do that, let me do something real quick. Let me see if my poll works here. So I'm curious out of the class, this poll, it's asking, can you solve that? Yes or no? Just tell me, the question is really not, can you solve it? The question is, do you remember seeing synthetic division? Like, does this look somewhat familiar to you? Yes or no? I'm just trying to see where we are. I'm not saying you have to be perfect at the synthetic, but okay. So, about 84% of you, 16 out of the 19 respondents say that you've seen this before. And there's about 3 that have responded that this looks completely foreign. So remember, if what I said, if this looks crazy to you, just try and pay attention for now and then get with me or get with tutoring for help on this. The synthetic division is not going to come up that often in this class, but it is definitely something that does peek its head out in future classes, Cal 2 and It's just a skill you should have to be able to factor. All right, so I'm going to continue. What I do now is I drop this 1 down, goes here, and then I multiply these two together. 1 times 1, I put it underneath here. And then I add down again, I get -1. I multiply here and here, I get -1, I put it underneath here. I add down, I get -1, and then I multiply a last time, and I get -1, add down one last time, and I get 0. And those of you who've done synthetic division before know that if you get 0, that's what you're hoping for. You're hoping to get a 0 down here. Because if you get a 0, here's what synthetic division tells you. It tells you that if you take that number, x, that's a 1, if you create a factor from it, in other words, put x minus 1, and then you look at these 3 numbers right here, those 3 numbers are the coefficients of the remaining polynomial. This synthetic division basically allows us to factor the numerator. What we've done here is we've taken this, and by using synthetic division, we have broken it down to be this. That's the whole point of what we just did, is that it is a way to factor. So that means I can rewrite the original limit that I had here. The numerator is now x minus 1, x squared minus x minus 1 over the x minus 1. And the whole point of that was so that we could get the x minus 1s to cancel. Don't freak out if the synthetic is like, oh my gosh, everything was going fine until I saw that. Just, it's not the end of the world, but you need to make sure that you get, refreshed on that. So those factors cancel, and now I just let x go to 1. So let's let x go to 1 now. This becomes 1 squared minus 1 minus 1, which I believe turns out to be -1. Oh, I forgot to put the 1, -1. Are we done? What have we found?
The slope.
The slope
Just
of
the
the
slope, right? I wanted the equation, though, of the line. So to get the equation, we need a point and a slope, right? A point and a slope. So we're going to go use this formula now, this one right here. That. So now using this for the equation of the tangent line, we're going to use y minus f of a equals the answer we just got, -1, and then x minus a. This is the same as plugging 3 into the function. Yeah, wait, no, we weren't plugging in 3. What were we plugging in? 1. I messed up. We plug in 1 here. And then -1 is the answer we just got right there. And then x minus 1. And what was f of 1 again? When we plugged 1 into the original function, didn't we get -1? We did that. Where did we do that? We did that right here, right? Right there. We plugged 1 into the original function and we got -1. So we already know that that's going to be a -1 from earlier. And then over here, -1 times x minus 1. So I'm cleaning up now. Y plus 1 equals, I'm going to distribute -x plus 1. And if I subtract 1 on both sides, I just get y equals -x. That's the equation of the line. So I'm going to come over here and take all this other stuff out of here so you don't see it. We were trying to find the equation of the tangent line at that point for this curve, right? And we found that it was just y equals -x. There it is. I hope that you agree with me that that line is the tangent line to that curve at that point. What do y'all think? I mean, other than the synthetic division, that part sucking, like, is everything else making sense? Like just executing the formula? Yeah.
And you said we would have to memorize that formula, the f of x and f of a formula?
Yes. And the reason I'm expecting that for the test is just because there's really nothing here that's new. It's the point slope formula from college algebra. It's the rise over run formula, and then just we're throwing a limit in front of it. I think everyone can get this burned into the brain in a week. I won't ask you to memorize a ton of stuff in this class, but that's one of them I want you to know. All right, let's do another one. All right. So this time put find equation of tangent line to the function f of x equals the square root of x minus 3 at the point 4, 1. So the wording of this problem is slightly different than the wording of the previous problems. Let me give you a moment to jot that down. And then while you're jotting that down, I'm going to actually graph this thing. Okay. So here's what we're looking at. There's the graph of that function. And we're looking at that point 4, 1, right? And what we're trying to figure out is what is the equation of the line that is tangent to that curve, right? So we're trying to find a line that's going to look something like this when we're done. It's going to come through and just touch through that point just like that, right? So we should expect to see a positive slope, right? We shouldn't expect to see something like this, right? That's not tangent. Okay, let's go get it. So what do you think we should do first? What do y'all want to do first? Slope of the tangent first, right? Figure out what that is. Let's figure out what the slope is, then we'll get the equation. The slope of the tangent would be the limit x approaches a, f of x minus f of a over x minus a. That's our generic formula that we're going to memorize. Now, like I said, the wording on this one's a little different. It's this problem, the information I gave you is actually going to make your life a little bit easier, because the 4 and the 1, can somebody tell me what those two things are? Like, what's the 4? For us, it's what?
The x.
The x, or the a, right? It's the value of a. It's that anchor point. So this is the a, right? And then what's the 1?
Why?
Yeah, but what is it though?
The f of x.
F of a. It's the f of a.
F of a.
What you get when you plug 4 into the function, right? This right here is f of a, right? Think about it. If you plug 4 into this, right? 4 take away 3 would be 1, and then the square root of 1 is 1. So in the previous problems, all I gave you was the a, right? I told you like x equals 3 or x equals 1. I only gave you one of the pieces, and then we had to go find the other piece. Here, if I give you the point, I'm actually giving you both the a and the f of a, which is nice because it makes your life easier, right? So I'm going to rewrite this. Limit x is going to approach 4. F of x is the original function. minus f of a, which is 1. All over, you know what? Let me go a little slower. This is f of, well, I think I can put it here, 1. All over x minus 4. Who has a question on that? Anybody? All right. I'm going to give you 4 minutes. Work alone. I'm not going to do breakout rooms. I can do that, but I'm going to give you 4 minutes to see if you can get that limit. And when you get it, go, if you are capable of doing it, go to the chat and just put your answer in. And I'm going to make it where you can just chat with me. And I believe if I do that, no one else will be able to see your answer. So you don't have to be afraid of being wrong. All right, I'm gonna give you about 4 minutes, see if you can calculate that limit. So all I'm asking for is this to calculate the limit. You don't have to finish the whole problem. I just want to know what this limit is giving you. I'm going to go 2 more minutes. Okay, let's talk about this. I'm getting some answers. Some of them are right, some of them are wrong. Let's work through this. All right, so conjugate should be the number one step, right? You got 0 over 0, so you need some algebra. Okay, here's my work. So I take the conjugate on the top and the bottom, and then when I multiply out the top, I do here to here, the roots go away, get x minus 3. That's this part right here. I don't have to do the middle multiplications because I know they'll cancel out. So I just do this times this. That's -1. That's this. And then on the bottom, I do not multiply these out, right? Remember, our whole goal is to try and get this x minus 4 to cancel because that's the part that's causing the division by 0. So I leave that x minus 4 here. And then fortunately for us, the x minus 3 minus 1 becomes an x minus 4. And that will cancel directly with the x minus 4 on the bottom, leaving a 1 on top. And then when I let x go to 4 right here, I get 4 minus 3 is 1, and the square root of 1 is 1. So all of that becomes a 1, and 1 plus 1 on the bottom is 2, so you get a half. I got all sorts of answers. Let me see. Of the people who answered, let me see, I got half. 1, 2, 3, 4, 5. 5 people got it right. 1, 2, 3, 4. 4 or 5 people got it wrong. So you got to be careful with this, right? You got to take your time. And this is why it's so important that we are comfortable with limits, because it's hard for us to ever find equations of tangent lines if we can't do the limits. All right, we keep going. All right. Any questions though on this approach? Anyone who got it wrong, see what you did wrong? Yeah. Okay. All right. So that's the slope. Now watch the way I'm going to do the equation. I could write this whole thing down, right? Or I'm going to write this whole thing down. The slope I got was 1/2, and then x minus a. I know that f of a, we said wait earlier, f of a was 1, so that's just a 1, equals 1/2, and then x minus the a was 4, so x minus 4. And I told you, you could just use that on the test as an answer. That's okay. Any questions on that? You'll have to pay attention on the exam next week. Sometimes I will ask for just the slope of the tangent line, and sometimes I will ask for the equation. If I ask for the slope, all you're going to give me is 1/2. If I ask for the equation, you got to give me all this. Let's check our answer. Let me graph that. I'm going to see if it looks like we got it right. Y minus 1 equals 1/2 x minus 4. There we go. Does that look like the tangent line to you through that point? Yeah. Okay.
Is that
Yeah.
on Tuesday or Thursday? I'm sorry.
Thursday.
Okay, thank you.
Yeah, and I will send out a review, something for you to look at. But again, focus on the homework and what we do. Go back and look at the lectures, what we did in class, the problems we did in class, and then just kind of study everything. All right, I have a question for you here. This problem right here. I'd like to look at it again, but I'm going to have multiple parts to this. I want you to find the equation of the line to this curve at, let me change this. Part A, I want you to do it at the point, let me see. Oh, I got to think for a second here. 4, what am I doing? Um, 12, 12.3, and then 19.4, and then I want you to do it at 28.5, and then I want you to do it at 39.5. 6. Okay, now just write that down and then let's talk about what I'm asking you to do. It's the same problem that we just did, right? It's the same thing we just did, but now our A and F of A are different, aren't they? Our A and F of A are different. I've actually given you 4 new A's and F of A's, haven't I? Which means you'd have to do 4 limits, which means you'd have to do a lot of work, right? This is a lot of work to have to do, yeah? So maybe there's a more efficient way of doing this. Maybe instead of trying to find the equation of the tangent line and doing each one of these problems one by one, maybe what we can do is try and find the equation of the tangent line at some arbitrary point. Okay, this is where people start to be like, okay, hold on, what are you talking about? Watch what I do, see if you can follow along with this. So I'm gonna say, forget this for right now, all right? And instead of doing that, let's try and find the equation of the tangent line to this at some arbitrary point A, F of A. See, I'm not actually going to tell you what the A is and what F of A is. It's going to be arbitrary. Let's see what happens to the algebra if we do this. So let's begin by first trying to find the slope of the tangent line, which by definition is the limit as x approaches A of f of x minus f of A over x minus A. All right, that's the definition. But here, I'm not telling you what A is, right? So you're not going to be able to replace this A with, 4 or anything else. You're just going to leave the A as A. It's some number we don't know, right? So I'm going to keep going. What is f of x? Well, that's what you get when you plug x into the function. What do you get when you plug x into the function? Just the square root of x minus 3, right? That's what you get. And then you subtract from that, now the critical step. What happens when you plug in A into the function? What do you get?
It'd be square root of A minus 3?
Yep, square root of A minus 3, right? And then all of that is going to be divided by x minus A, right? And again, you can't replace A. We're not replacing A with a number. Look, here's what I'm trying to do. Somebody's asking me to find the slope of the tangent line at 4 different places. What I'm trying to do is use a generic variable A instead of the numbers they're giving me. And if I can come up with a formula for this, work this out and come up with a formula at the end, then I can just plug in those values for A individually and not have to do the limit 4 different times. I'm going to only have to do the limit once. So what I'm doing is like cutting down on the amount of work that I'm going to have to do if I can do this limit. This limit still looks terrible though, because if I let x go to A, that becomes an A there, that becomes an A there, and I get 0 over 0, right? I get 0 divided by 0. So I'm going to have to do some algebra right now. Does anyone have an idea of what algebra I'm going to do to make this limit work? What am I doing here? What am I going to multiply top and bottom by?
The
The
conjugate.
conjugate.
Conjugate, right? Conjugate. So it's going to be square root of x minus 3 plus the square root of A minus 3. I know that looks bad. Square root of x minus 3 plus square root of A minus 3. And now I multiply out. All right, when I go here to here, the roots go away. I get x minus 3. The middle terms will cancel for sure. be really careful on this one. We're doing this times this. Positive or negative? What are we going to get? Negative. Okay, negative, and then what?
A minus 3.
A minus 3. We have to put that A minus 3 in parentheses. That is a critical thing to see, because you're subtracting whatever happens when you put those two roots together. And if the two roots together give you an A minus 3, you have to subtract that whole expression. So you have to have a set of parentheses around the A minus 3 so that this negative will distribute through. A lot of students miss that, and they don't put the parenthesis, and then things never work out because of that. Now on the bottom, I am not going to multiply this out. I'm just going to leave it as x minus a out front, and then this big ugly looking thing, square root of x minus 3 plus square root of a minus 3. And what happens upstairs here? What is all this going to become? Go ahead and distribute the negative, and what do you get?
Negative a plus 3.
Negative a. Okay, yeah, if we distribute, you get, so we have x minus 3 minus a plus 3. And then what happens to the 3's?
Cancel.
Cancel, and you're left with just x minus a up top, right?
Yes.
And that cancels with the x minus a on the bottom, which leaves you with limit x approaches a of, on top we have a 1 because everything canceled out, and on the bottom we have that ugly thing, don't we? It's ugly, but it's what we have, right? We're almost there. I'm now going to let x go to a. So everywhere I see an x, I'm going to replace it with an a, and we're no longer going to get 0 over 0. We are going to get, so no more limit because I'm letting x become a. We're going to get 1 over the square root of a minus 3 plus the square root of a minus 3. And when you do that, on the bottom, when you add those two roots together, because they're the same roots, it's like taking an apple and adding an apple, you should get 2 apples. So here we should get 2 square root of a minus 3. And that is our generic answer. This is extremely powerful now, because what I've done is I've come up with a generic formula that will always give you the slope of the tangent line at any value of a you want to plug in. You can give me any value of a now, and I will tell you the slope of the tangent line there. So let me copy this. Put it right here. And now let me come back and answer. I'm not going to answer part A, B, C, and D like completely, because remember I was looking for the equation of the tangent line. Let me at least tell you what the slope is. So what is the slope of the tangent line here? Well, what I would do is I would use this formula, and I'd replace A with what?
12.
12, right? Because this is A. So it'll be 1 over 2 times, okay, what's 12 minus 3? I'll write it down, 12 minus 3. Let me move this over. 12 minus 3 is 9, right? And the square root of 9 is
3.
3. So this would be 1 over 2 times 3, which is 1/6. So now, do y'all see that you have the slope and you have a point? If you have the point and the slope, can you give me the equation? Yes. Okay, now for the next one, same thing. If I want the slope of the tangent line here, I use that formula again, 1 over 2 square root of, this time I'm going to put 19 minus 3. 19 minus 3 is 16. The square root of 16 is 4, so I get 1/8. And again, I have a slope and I have a point, so I could come up with the equation. Do you see how that formula is actually really powerful because it allows me to not have to do the limit like 4 different times? I can just do it one time, and that might suck, but once I get through it, I've got a generic formula that will work all the time for any point. Yeah. All right.
So that generic formula, are we supposed to do all that to get it?
Everything we did right here is what would be required to find that generic formula.
Okay.
Okay. So let me, yeah, go ahead.
How did you get the 2 in the formula?
Oh, okay. Whoa, what happened here? Let's just say that that's an apple. And that's an apple.
Okay.
And if you add 2 apples, I mean, if you add an apple and an apple together, you get 2 of the apples, right? I'm not multiplying them. If I multiply them, the roots would go away, wouldn't they? But if you add them, they're considered like radicals. They're exactly the same radicals. So when you add them together, you just get 2 of them.
Okay.
Is that what you're asking?
Yeah.
Okay.
Really quick. So this formula, it's only for this arbitrary value that you made. So we'll have to do these steps again in order for another problem.
Yes. So this formula only works for this function. If I give you a different function, you would have to go through this whole thing again, and you would come up with a different formula. I have 10 minutes. So I was going to try and do it on one more, so you could see, like, can we come up with the generic formula for another function? All right. So how about for this one? Let's take the very first problem we started with. F of x equals x squared. This one will go a little faster. All right. What I'd like for you to do is find a formula for just the slope of the tangent line. Okay. I'm not asking you to find the equation. Just find a formula for the slope tangent line at x equals a. So at some arbitrary point A, I want us to come up with a formula for that function that would always give us the slope of the tangent line at that point. So I write down what the definition is for the slope of tangent line. It's the limit as x approaches a of f of x minus f of a over x minus a, which for us here would be the limit as x approaches a. See, I'm not replacing a with anything. And now, what is f of x? Well, that's what the original function is, right? So that's, for us, that's x squared. Minus, what is f of a? Well, that's what we get when we plug a into the function. So for us here, it should be a squared, right? A squared over x minus a. That doesn't change. And the algebra on this one is a little easier than the one we just did, right? Do you all see the algebra? Just difference of squares. So this becomes limit x approaches a. Go ahead and factor difference of squares on top. The x minus a's cancel. So you're doing the limit as x approaches a of the only thing that's left there, which is x plus a. And now let x become a, right? Replace your x with a. You get a plus a, and a plus a is 2a. And that's our generic formula. I went fast through that, but do y'all follow all the algebra there? I mean, it was pretty clean algebra, so I went quickly. So now, you tell me, what is the slope of the tangent line at x equals, let's say, 3? What would it be?
6.
6. Okay, what's the slope of the tangent line at x equals -2?
-4.
-4. So all you're doing is you're plugging in whatever the x value is into that formula. graphically, here's what we can say. This is the function we were looking at, x squared. If you go to the x value of 3 on this graph, if you go to that x value right there, okay, x value of 3, go there, we should expect the slope of the line to be 6, right? And if we go to -2, right there, see that point right there, the x value is -2. What's the slope of the tangent line there? According to what we just found. At -2, we should expect the line to have a slope of -4, yes? All right, here's the big question. Let's see if you can put this together. At what x value would the slope be 0? Go to this right here, go to this, and I'm asking you basically, give me the a that would make this thing 0.
It'd be 0, wouldn't it?
It'd be 0, right? And does that match up with our graph? Look at our graph. If you go to the x value of 0, right? If you go to the x value of 0, hey, guess what? The slope of the tangent line there is 0, right? The slope of the tangent line there is 0. Remember I said in the very beginning, our goal is going to be to try and find the peaks and valleys of a graph. And if we can come up with a generic formula for the slope of the tangent line, then we could ask ourselves, when is that generic formula equal to 0? And that should tell us everywhere we have flat lines. And everywhere we have flat tangent lines should correspond to peaks and valleys. Okay, I'm getting ahead of myself. That's coming. I need one more thing in the last couple of minutes here. I'm going to go to my actual lecture notes. Okay, right here. So as of right now, we've only done half of what we need to do in this section. All right, so right now I want you to ignore this for now, okay? This right here is what we did today, right? We said, hey, look, if you want to find the slope of the tangent line, we're going to use that formula, right? Now, this idea of finding the slope of the tangent line is so important and used so much in the rest of calculus. We have a special name for this procedure and for what it's doing. And it is called the derivative of the function at the number a. And we have a special notation for it. And this is the notation right here. And the way you say that, you say, the way you actually say this like verbally is you say the derivative of f at a, or you can also say f prime of a. So let me go back to the example we did. We're going to get more practice with this language, but what I'm saying to you is this. This right here is the derivative f prime of that function at a. That's what it is. We call it the derivative of the function at a. In the previous example we did, the derivative of this function, this one right here, see that function right now? If I asked you, hey, what is the derivative of this function at a? If I asked you what that was, your answer would be that right there. The derivative of a function at a is simply the slope of the tangent line at some arbitrary point a. So what I'd like for you to do for homework out of this section, just ignore what's on your calendar for now. Out of 2.1, I want you to do, so this is out of 2.1, I want you to do (1A), (2A), (3 through 6), and then you can really kind of go for it. Try to do 25 through 20. Well, let's be ambitious. 25 through 30. Now, when you do these first two, it's going to say in the instructions to find, it's asking you to find the slope of a tangent line for those, and they give you a point, and they ask you to use both definitions. We have only learned one of the definitions. So just use what we did today, the limit x approaches a, f of x minus f of a all over x minus a. Use that and ignore the other definition. All right, these three, they're asking the same thing. They give you a function, they give you a point. So these are all done the same way. These are the f prime of a. This is where we're trying to find generic formulas. All right. So in the beginning of class, we were doing it for each point. We just ground out the problem. We got a numerical answer. And at the end of class, I said, okay, well, now let's do it arbitrarily for any value of a. That's what the 25 through 30 homework problems are. All right. Do what you can, do your best. We'll be back on Tuesday in class, right? Look for that little review that I send out and come with questions. The stuff we covered today will be on the exam. But next class, whatever we do will not be on the exam. All right, so what we do on Tuesday will not appear on the test that's 2 days later. All right, good luck with your homework. You'll have a great weekend.
I have a question.
Yep.